Okay, so for the paper 4, physics A-level paper 4, important graphs for the whole paper. The first graph, gravitational field strength at the y-axis and the distance from the center of the planet at the x-axis for the isolated object, isolated planet. So this is the graph. Then if the graph is required between two planets, then this is the resultant graph. So inside the planet, directly proportional, outside inversely, but here the resultant G is 0. And the next, number 3, is this is the gravitational potential and the distance graph. And then energy in the orbit. So this is the radius of the orbit at the x-axis, energy at the y-axis. This is the kinetic energy, this is the total energy, and this is the potential energy in the orbit. And the next is about the simple harmonic motion. This is acceleration displacement graph. This is displacement and time graph, and the motion is starting from the mean position. This is the velocity against time graph. This is acceleration against time graph. And this is the velocity and displacement graph for the simple harmonic motion. And this is damping graph. The amplitude is gradually decreasing, but the time period, frequency, the angular speed remain same. This is amplitude against frequency for the resonance. This outer line for the undamped system. This is for the light damped system. And this is for heavily damped system resonance. Then for the ideal gas, so this is pressure volume graph. Then this is the change of temperature against time. And then electric field. This is the electric field strength and the distance graph for the isolated charged sphere. Inside the sphere, electric field is 0 at the surface maximum, that then decreases gradually. Then this is the potential against distance graph for the isolated sphere. This is electric field strength between two similar charges. This is electric field strength between two opposite charges. This is the potential between two opposite charges, oppositely charged sphere. This is the electric potential between two similar charges. And this is the electric potential energy. This line when charges are similar. This is the line when the charges are opposite. And then capacitance during charging. This is current time graph. And here is the charge time graph. Here is the voltage time graph. Here the charge and voltage. Then for the discharging, voltage and charge at the y-axis, time at the x-axis. If the resistance is large, time is large. If the resistance is small, mean through which across which the capacitor is discharging. If the resistance is small, then the time is small. Then the magnetism, induction, this is a flux time. This is the voltage, sinusoidal in alternating voltage. This is the EMF induced. If this is the voltage graph, this will be the current graph, and this will be the magnetic flux graph. Then this is the induced EMF graph. Then this is the voltage time, current time, but the RMS value will be V0 over under root 2, I0 over under 2 for the IRMS. But if the voltage is a square wave, then VRMS exactly equal to V0. So these are the formula only for the sine wave. And here is the smoothing of the ripples of the voltage after rectification. Then the radioactivity. So the parent nucleus is decreasing exponentially and the daughter nucleus is increasing exponentially. And this is the half-life. Then for the particle physics, this is the intensity and thickness graph. And where the intensity becomes half, that thickness is called the linear, half value thickness, x half. Then cosmology and astronomy. This is the flux intensity against 1 over d square, f and d square. This is the power density against the lambda. Then recessional velocity is equal to D, mean V is equal to H naught T. And then this is about the quantum, kinetic energy against frequency. This is the threshold frequency. This is the work function energy, and the gradient is Planck constant. If the stopping potential against frequency, then this is threshold frequency. The gradient is now H over E. E is the charge of the electron, and this y-intercept is minus pi divided by E. So these are the important graphs for the paper 4. Okay, thank you.